Well, tonight's speaker is Brian Grant. He's spoken to this group before. It was a really successful meeting and very interesting. He is a senior analytics consultant at CSG Pro, which is based in Portland. They're part of the Microsoft Certified Partner Network for Data Management and Analytics. And Brian does a lot of Power BI training, visualizations, DAX, and also data platform work. And with that, I'm going to turn things over to Brian.
Okay, so my presentation today is going to be about seeing inside of DAX, which is Power BI's advanced calculation language. And as a bit of a preview of things to come, it's mostly just tables. In fact, it's almost entirely just tables. So let's start with a pretty simple definition. Here, give me 1 second. Let's improve the experience here for you guys. Go away, taskbar. I hate tasks. Okay. So let's start with a simple question. What is DAX, right? Because I know a lot of people who have been writing DAX for months, maybe, well, not quite years, but a long time, and they ask the question, hey, by the way, what is DAX? And they're like, I have no idea. It's this thing that I write periodically. I'm not quite sure what it does. I sort of know how to do it, and it scares me. DAX is really quite simple. DAX is the querying language that builds summary tables on demand for Power BI. So what do we mean by that? In Power BI, and it also works with analysis services, but let's just focus on Power BI for right now. What you do is you use this Get Data button right up here to build a process to load highly detailed tables into your data model. So things like sales tables, where maybe you have 13 million rows of sales transaction, maybe a products table with all your products, maybe a stores table with all your stores, but the most detailed information you have, right? So you load that data into something called the data model, and then the DAX engine is in charge of summarizing that highly detailed data on demand, right? And what do we mean by on demand? Well, if I come down here to this slicer, if I just uncheck that, boom, it re-summarized the data. If I click on premium, boom, just like that, it re-summarized the data. These are not pre-cached results. The DAX engine is summarizing this stuff on demand, okay? So how does this fit into the larger Power BI universe? So like I said before, you start with sources. You know, you've got maybe a SQL database, maybe an Excel file, maybe an Access database that you've been trying to kill, but you can't. You go get data from those data sources using the M language, which is to say this Get Data button up here. You load that into the physical tables of your data model, usually about once a night. Then the DAX engine on demand builds these summary tables. And the reason it builds these summary tables is because Power BI is going to draw them as visuals, okay? So I should add, right here I say that this is a summary table. Right now this is actually a table visual in Power BI, but it's a good approximation of what a summary table might look like, right? And so every time I click on a slicer to interact with my visuals, Power BI is spinning up a new summary table. I'm sorry, the DAX engine, should say, is spinning up a new summary table, which Power BI then draws as a visual, okay? So some folks might say to themselves, this sounds an awful lot like pivot tables. And yeah, it's the same general kind of idea, right? With a pivot table, you load detailed information into a range in an Excel workbook. You then say insert pivot table, which loads that data into the pivot cache. Then you use these pivot table controls to say, I want to see sale amount sum and margin amount sum by year part and so with values on top. And sure enough, the pivot engine spins up this summarization for you. It's the same general idea. However, DAX can work on much larger sets of data. It could work on data models where you have multiple tables connected together, and it could do really advanced calculations, things like year-over-year growth or returning customers, stuff far more complicated than simple sums and averages, okay? So let's revisit this idea one more time, because I think it's super duper important, The idea of DAX within the Power BI universe is DAX is the thing that builds these summary tables, which Power BI draws as visuals. So anytime you see a Power BI visual, right, there is always a summary table behind it. But by the way, summary table is my way of describing the result of a DAX query. If you've heard that term before, that's just fine. It's the same idea. I refer to it as a summary table because it's always a table and it's always summarizing your data, right? So if you've got sales over time, where you've got total sales broken down by year and quarter, well, sure enough, the DAX engine spun up a summary table with total sales broken down by year and quarter, which Power BI then drew. if you've got total sales broken down by category and location, well, sure enough, the DAX engine had to spin up a summary table that looks like this, which had total sales by category and I guess city right there, right? And every time you slice and dice, right, the DAX engine spins up new summary tables, which Power BI then draws as these visuals over here. I do tend to talk kind of fast. I will pause for a moment. Are there any questions about what I've talked about so far? Anybody want to go down a rabbit hole and talk about pivot caches with me? Give folks a second. Okay. So I just want to emphasize, it's not entirely clear. The basic idea here is every time you have a shape in a visual, the technical term for this is a glyph, but every time you have like a geometric shape, like one of these columns or a bar or a slice of a bar chart or a point on a data on a line chart, right? Every single one of those elements in a visual corresponds to a line in a summary table, right? So this bar down here where we're looking at total sales for food in Washington, well, that corresponds to a row in a summary table where you've got total sales for food and Washington, right? And down here where you've got, like, I've got that 14 million for sit-down sales in 2018, well, that's going to correspond to this row right here where we've got total sales for sit-down in 2018, right? So every single time you see a data point in a visual, that is a row in a summary table, and it's the DAX engine's job to build those summary tables for Power BI to render, okay? So, all right, I think I kind of get it, but how do these things come into being, right? Well, let's look at that path for just a moment. So you might do something in Power BI where you load data into your data model. You use the get data button, load data over here, and then you use the Power BI interface to maybe create a column chart, and then you drag state into the access, category to the legend, and total sales into values. When you do that, Power BI says, okay, I need to draw this visual right here, which is going to have total sales broken down by category and state. So what it does is it says, I'm going to write a summary query or a DAX query, right? This is like an order form for a summary table. What summarization do I need? And if I need to draw a visual with total sales by category and state, well, then the summary query is going to say, go get total sales and break it down by category and by state, okay? So the Power BI writes this summary query, which is like an order form or a request form, sends it to the DAX engine, and the DAX engine, lickety-split, spins up a summary table, right, with total sales broken down by category and by state, which it sends back to Power BI, which Power BI then draws as this visual, or frankly, any other number of visuals, okay? I think, was that a question that I saw in the chat window? Or not?
Yeah, the question was, will this Power BI PBIX file be shared?
I need to discuss this with my coworker because I want to, but I want to make sure that we're not violating any strategic plans marketing-wise. But hopefully the answer is yes. So I hope to be able to get it to you, right? Because you're probably thinking about, hey, where'd you get that DAX measure right there, right? I'll do that part in the Q&A if that's what you're curious about. Okay, so you drag and drop stuff into the interface. Power BI writes a summary query, sends it to the DAX engine. DAX engine builds up a summary table, sends it back to Power BI. Power BI then draws it as this visual right here, okay? Now, what's meaningful about this is anytime you interact with a report by, say, clicking on 2017, right? When I click on 2017, well, sure enough, the visual changes, but the reason the visual changes is when I click on it, Power BI detects that, writes a new summary query with essentially the same request, but adding a little line here where it says, by the way, add a filter for year equals 2017. Sends that over to the DAX engine. DAX engine re-summarizes it, now just looking at 2017, and Power BI is able to redraw the visual with just 2017 data. And if I click on state equals Oregon here, well, boom, it adds a filter for state equals Oregon, sends it to DAX. DAX re-summarizes, and the numbers get smaller and smaller. This is also true for things like cross-filtering. So if I click on this walk-up here, right, the visual gets smaller over here, smaller and smaller and smaller. The reason it's getting smaller, Power BI detects that change, rewrites a summary query, sends it off to DAX to re-summarize. DAX re-summarizes it, sends it back to Power BI, and Power BI draws it, okay? So that is how all this stuff works. Any questions about that? Pause for a moment. By the way, another name for a summary query is just a DAX query. Since you're always doing summarizations, I like to call them summary queries. You may hear them referred to just as DAX queries, but the name DAX query doesn't tell me all that much.
Can I ask a question?
Please do.
where can we see the summary query? Where is that? Is it published someplace in the PBIX, or can we display it?
So this particular summary query is probably going to be slightly simpler than the ones that you will actually see, but yeah, you can totally see it, right? And it's going to have some more stuff on there to speed it up, but I can show it to you. So I'm going to go to here to view, and I'm going to turn on the performance analyzer. And basically you can't see anything, which is my secret. That way if I mess up, you guys can't see what I'm messing up. So I'm going to start recording, right? So I'm recording the performance analyzer, and I'm going to click on something like, let's just click on 2017 here, right? Boom, there we go. Okay, so now I got to go figure out which, what is this referred to? So that is probably the table, I'm thinking. I probably could have named these things better. It would make this portion of the video a lot more interesting. So here when you open it up, right, so when I clicked on the slicer, notice how it spun off all these summary, it's actually several events in here. One of them is the summary query or the DAX query, which is go resummarize the data, sends it to DAX and gets it back in a little over than a second. Then it has to draw it, and then there's some other administrative stuff in there. To your question though, here where it says copy query, you can hit the copy button and open up my very favorite development environment, which is to say Notepad, and you can paste it in there, right? And it looks a little more complicated than the stuff that I've got, but not a lot, right? You can see that summarized columns, break down total sales by category and by state, and there it is. And you can even see this weird goofiness where I just wrote year equals 2017. They use this treat as function, which does the exact same thing, but is a little bit faster, which is why, since most people can't see this stuff, they did the faster, harder to read version. Does that answer your question, or does that go beyond what you were hoping I would answer?
No, that is absolutely perfect. Thank you very much.
Fabulous. And I should add, right? You could take this summary query, right? Gosh, I hope this works. And you can open up something like an external tool, right? I always get nervous when there's a video being recorded, right? So you open up an external tool like DAX Studio, right? And you come in here and you could actually just paste it, right? And you have to go up top and say evaluate, which basically says, hey, go do this thing, right? And then when you run it, let's see, it got an error. Oh, what don't you like? Oh, wait, there's two evaluates, that's why. Pay no attention to the man behind the curtain. There we go. There's that summary query, or there's, I should say, this is the summary query up here, and this down here is the summary table that got sent back to Power BI, which Power BI then drew as that visual right there. Is that helpful?
Absolutely perfect. Thank you very much, Brian.
Fabulous. Happy to help. Okay.
Hey,
So
Brian, you had one more question.
sure.
It was, will DAX still be available in Excel for building out measures and calculated columns, parentheses, categories?
I mean, so yes, and there's probably several reasons for that. Number one, Excel is still like the main analytical tool that Microsoft sells just in terms of volume. I'm biased. I like Power BI better, even though I came from the Excel world. But so the Power BI, as we refer to it now, actually used to be several add-ins for Excel, Power Pivot, Power Query, Power View, and I think Power Maps. And so they spent all this time baking those features into Excel. And it was only afterwards they were like, hey, you know what, this might make a better product on its own. But they invested all that time and energy. So I don't see that going anywhere. I think that's going to stick around for a long, long time. So that Power Pivot experience. I'm not sure if they still brand it Power Pivot, but I think they say things like add to data model and stuff like that. Same kind of idea. Does that, let me know if that answers your question, or if it doesn't, give me a follow-up. Okay, so hey, we sort of get the idea here, right? We interact with these slicers and the cross filtering. It rewrites a summary query, which builds a summary table, and we get the visual. Hooray, thumbs up. What you might be asking at this point, especially if you're pretty new to DAX, is I kind of get, give me all the combinations of state and category. I kind of get this year equals 2017 filter thing. But there, it just says total sales. Like, what is that? What is this magical thing that just magically produces these numbers right here? That is a measure, right? So let's go look at measures for a second. So measures are preset reusable formulas, which are designed to always answer the same question the same way. So if you've got a question such as, what is total sales? Unlike Excel, where you can define it on a cell-by-cell basis and make as many mistakes as you would like, in the world of Power BI and DAX in general, you create a measure called total sales and say, hey, I have a business question called what is total sales? And I'm always going to answer it this same way, right? And then when I drag the measure into any number of visuals, I will know that both on this visual and on this visual, I'm calculating totals of sales the same way because I'm always using the exact same measure, which uses the same formula. And if I want to change the way it's being calculated, I just open up that measure, make whatever changes I want to make, and then boom, then instantly, all the way across all my different pages of my report, everywhere that I'm using total sales is instantly fixed, which is a very nice way to sort of manage your code. So when you've got these summary tables, they basically have two sections. They've got the grouping columns, which is all the different category combinations, like all the different state and layout combinations, Oregon sit down, Washington walk up, maybe what are all the different years, maybe years and quarters. And then you also have the measure columns, which are all the different answers for each individual combination, okay? And when people say they want to learn how to write DAX, usually what they mean is they want to learn how to write measures. There are certainly other things you could do with DAX, but for the most part, most people experience writing DAX by writing measures. So when you say you want to get good at writing measures, you basically, or get good at writing DAX, you get good at writing things just like this, okay? Any other questions pop up? Let's see. I didn't see anything in the chat window.
Nope.
Fabulous,
nope.
fabulous, fabulous. Okay, so the cool thing about learning to write DAX is it's going to unlock all kinds of very complex, dynamic calculations in Power BI. Everything from simple ratios like a margin percentage or a shipping cost percentage, goal to actual variance as a percentage in dollars, to more complex things like year, quarter, month-to-date sales, a rolling 52-week average, year-over-year sales growth, number of returning, new or lost customers, dynamic sales ranking, what-if scenario adjustments. Anything that you need to be dynamic, you could generally do with the DAX language, even over very large sets of data. So it's strongly recommended that within your organization, you have at least a handful of people that have a DAX expertise, because those are the folks that are going to allow you to report with dynamic calculations like this, to which you might reply, that sounds annoying. I'll just do the thing in SQL, right? I spent all these years learning SQL, or maybe I spent all these years learning Power Query, or I spent all these years learning Excel. I don't want to have to calculate this stuff in DAX. I don't want to have to learn a new language. What I'll do is, when I load my stores table, I'll just use SQL or Excel or Power Query to just add a column called, I don't know, distinct customers or whatever you want, right? Now, there are situations where that can work okay, but there's a problem with it. When you load this data into a table like your stores table right here, it is no longer dynamic. These are just static numbers. And if all you have to do is report on this exact grain with no additional filters, this can work okay. But there's two problems, right? If you take a column like this and try and drag it into a visual, it's going to roll up incorrectly and it is not going to cross filter. What do I mean by that? So here we have this column where I basically just took the column and dragged it into this matrix over here, right? And then we could see, if we look at the actual store level, the numbers tie back perfectly. There's that 4.3 for Beaverton, and there's that 4.3 right there, okay? However, there's a problem, right? When we get to the roll-up, like for Oregon or Washington, how is it rolling up those numbers? Well, it's just summing them up, right? And there may be cases where that works just fine, but if you're talking about distinct customers, it could very well be that you have one customer who has visited this store, and this store. So you don't want to count them 3 times here in your roll-up. You only want to count them once, right? If you take that same concept and use DAX to do it, what you will find is you get the correct roll-up. So this 10,000 right here is not the same thing as summing up these numbers. It's the actual distinct customers just for that state. Furthermore, watch what happens when I click on 2017 down here. I click on 2017, what would an end user expect? Well, I should just see the distinct customers for 2017. With the measure version, it works just fine. It adapts perfectly to different slicers and slicing and dicing. By contrast, this version over here, these are just dumb numbers in a static table, and so they don't filter accordingly. So that's sort of why you might have to do something in DAX. If you want that dynamic experience, if you want that roll-up experience, you kind of need to write your measures in DAX. And I'll pause again for questions and to remember to breathe. Any questions out there? Going once, going twice. Okay, Brian, that's fine, that's nice, that's dandy. How do you do it, right? DAX is notoriously difficult. DAX is simple, but it's neither intuitive nor transparent. It's neither of those things. So DAX is simple once you understand it, and if you don't understand it, you're kind of out of luck in some ways, right? The good news is there's only 3 main types of operations in DAX, and those operations interact in very consistent ways. The problem is you need to imagine what's happening without being able to actually see it. You can see the inputs and the outputs, but the process needs to be imagined in your head. There's no DAX version of evaluate formula. So you can see the data that you load, your physical tables, that's right over here. You can see your measure definition, and you can even kind of see the summary table showing that trick I showed you a minute ago. But how does the whole thing work? I don't know, magic maybe, right? Well, it's not magic, or maybe it is, right? It's a special kind of magic. Okay, so imagine this scenario right here, right? Where we simplify things even further. We've got a teeny tiny data model that's only got 7 rows in it right there, the micro table, right? And we've got a summary table where we've got to-go sales broken down by shift, and that measure is right there. Okay, we can even see the summary query that produces this summary table, but what happens in the middle? How do I get from this table in the data model and this measure and this summary query to an actual working summary table? The answer is not magic. It is, of course, more tables. So if you're hoping it was something other than tables, I apologize. Everything in DAX is tables, right? The sources are physical tables. The output is summary tables. In the middle are a bunch of temp tables, right? These are tables that exist just temporarily, just long enough in order to create this summary that we need, right? And one way you could even think of DAX, it's not a definition, but maybe a description of DAX, is the strategic procurement, manipulation, and application of temp tables. Everything in DAX is about temp tables. And the other bit of good news is there's just basically 3 ways to interact with these things, or 3 things that I refer to as elements, 3 kinds of operations. There's many, many, many functions, but there's 3 categories that you're going to concern yourself with. Table derivations, which create temp tables based on the physical tables over here and the current filters, right? Filter revisers, which change what filters are in place by adding tables. By the way, in DAX, even filters are tables. And lastly, iterators, which take a temp table and turn it into something valuable, like maybe a number for total sales, something like that. Okay. Now, it's worthwhile at this point. I'm trying not to make this a commercial. I want to keep this as neutral as possible. If you're hearing these terms and you're saying to yourself, I haven't heard these terms before, and I've read a lot of books on DAX, this is a mental framework that me and the folks at CSG Pro have put together that we refer to as the elements of DAX. It is not the same thing as the DAX language. It's a mental framework that sits on top of it. What do we mean by a mental framework? Well, we do things to make learning DAX easier. Things like categorizing functions so that we can illuminate common patterns that exist in the language. We take complex technical terms and we rename them with slightly easier to understand terms, even if they're slightly less precise. And we also hide a couple advanced concepts that frankly you just don't need while you're learning DAX. Which is another way of saying, if I'm using terms that you haven't heard before, that's why. This is part of this thing that we built for the community, right? So the cool thing about this, part of the reason we did it, is if you talk about these 3 elements, right, revisers, derivations, and iterators, they actually interact in very, very predictable ways. Now, my goal here is not for you to look at this image and instantly understand DAX, quite the opposite. It's still hard. But I do want you to look at it and say, oh, I get it. There's 1, 2, 3 kinds of things that I can do. And there's not that many ways that these things interact. The table derivations create the temp tables. The filter revisers change the filters by adding temp tables to the filters. And iterators take a temp table and turn it into something useful, like a number or another smaller table. Okay. So I said before that one of the hard things about DAX is that you have to imagine it in your head. And so one of the ways I like to help people start to see it is by sort of illustrating it for them in a language that you might be more familiar with. And by that, I mean Excel. So I'm going to use Excel to sort of show you how some of this stuff works. Now, before I do, I know I've said a lot of stuff. I'm going to pause for just a minute. Are there any questions so far? Any questions so far?
It's me again.
Yes, go for it.
So is there a place where we can see these temp tables?
No, that is the unfortunate part of it. There are ways to get hints about them, but there's no evaluate formula, and you can't actually see the temp tables. You have to imagine them in your head, which is part of the reason learning DAX is very, very tricky. The analogy I like to use, most folks, well, I don't know, a lot of folks play chess, right? I played chess when I was younger. There's an algebraic notation for chess where if you go read a book on chess, you don't see the chessboard. It just tells you, you know, DQ and B4, this piece moved to this piece moved to this square. When you're doing DAX, it's a lot like having to learn chess without actually being able to see the chessboard and only being able to see the notation. So I try and create these illustrations so that if you actually could see the temp tables moving around, it's a lot easier then later on to imagine them in your head. And so I hope the next session will make you happy, although you get to decide that. Is that sufficient for now? Maybe we can revisit the question in the Q&A section.
It's good.
Fabulous. Was that another question that popped up or something else? I saw something flash. Going once, going twice. All right. So let's imagine, I'm going to minimize this guy right here. Oh, hey, there's Notepad. And I'm going to try and find, there we go. I'm going to pop over here to a different PBIX file where we have a very simple data model. Very, very simple, right? So in this data model, we only have that same one table, teeny tiny table, right? It's only got 1, 2, 3, 4, 5, 6, 7 rows in it, right? And we've already built some measures, right? So I've already got some measures pre-populated. And so I could take a measure like total sales and just drag it onto this visual, and boom, like magic, it works. I could take average units and drag it onto this visual, and boom, like magic, it works. Dishes sold, right? I could just drag it on there, and like magic, it works. And the tricky thing is if you actually look at the measure, right? I could see the code, but I can't see what it's doing. To your point, I can't actually see those temp tables. I have to imagine what they're doing in my head, which is very, very difficult. So let's see if we can use Excel to sort of make this a bit more visible, right? Now remember, this is my physical table in the data model. This is what I use get data to load. And these are these summary tables that I'm building to summarize my data. Okay, here comes the exciting part of the presentation for me, where I hope I don't make too many mistakes. Okay, where are we going? There we go. So I'm going to open up this Excel file. And we're going to see some familiar stuff and some new stuff. We're going to simulate inside of Excel how DAX works, so that hopefully when you have to do it in your head, it's a little bit easier. Okay. So here, we're going to start by rebuilding this summary table right here, where we've got total sales broken down by shift. Now, again, we have 7 transactions here for some kind of a restaurant. They sell stuff at lunch, they sell stuff at dinner. They've got to-go sales and dine-in sales. I guess if this were a modern demo, everything would be to go. But for right now, people are still allowed to dine in, apparently, at this restaurant. And they could buy one of 3 dishes, pasta, burger, and one person bought a salad. One person decided to be healthy, right? We've got the number of units they sold with each transaction and also the price per unit, okay? So this is the data, this is the physical table in the data model. This is the data that we're going to summarize. And this is the summary table over here, right? The measure we're using is called total sales. And I've got it both here and here to show how we're getting the number on the top and show how we're getting the number on the bottom, okay? All right, so. We also see some temp tables over here, right? Specifically, these are my results of derivations, right? So a derivation is an operation, a thing that you type in that produces a temp table, right? So if I ask for the sales table, which is the name of this table right here, if I ask for the sales table in my code, like I do right there and like I do right there, right? I get all the visible rows of the sales table. Well, wait, Brian, what do you mean by the visible rows? Well, it's not just all the rows. It's just the rows that are visible depending on what filters are in the filter context. And right now, because the filter context is empty, if I were to ask for all the visible rows in sales, I would get all 1, 2, 3, 4, 5, 6, 7 rows. By contrast, if I were to come over here to my little magic box and add a filter for, say, lunch, I click on lunch, boom, right? I simulate revising the filters by adding the filter for shift equals lunch. That's what a filter looks like. It too is a table, just another temp table. And when I do that, suddenly that same derivation for sales that said, go get me all the visible rows in sales, doesn't get back 7 rows. It just gets back these 4 lunch rows because we've got a filter for lunch, right? If I click on to go, well, now I change the filter to go and I get these 4 rows, which are all the to go rows. If I click over here on lunch and dine in, now I'm pretending that I've got filters for shift equals lunch and type equals dine in. Well, under those filters, all the visible rows in sales is just this 1 row right here, okay? Now, notice over here, there's also these derivations that are non-respectful. And by non-respectful, I don't mean they hang out with cigarettes rolled up in their t-shirt. What I mean is they actually don't care about what the filters are. So if you were to ask for all of sales, you wouldn't get just the visible rows. you would get all 7, right? And so here, I'm going to pop over here and click on, oh, I don't know what's going on. Let's do lunch. Yeah, there we go. So I've revised the filters to have a filter for shift equals lunch. And now notice, if I ask for sales, I just get the lunch rows. If I do all sales, I get all 7 rows. I've also got this values function. And what the values function does is it says, go give me all the distinct visible values of a particular column, right? So since I've got a filter for shift equals lunch, the only visible shift is lunch. So I just get back that 1 row. And if you'll notice, during lunch, right, nobody bought a salad because everybody was being unhealthy. So if I ask for the values of the sales dish column, I just get pasta and burger, which are the distinct visible values given a filter of shift equals lunch. If I change this filter to dinner, well, now I've got a filter for dinner, and that same derivation, all the visible rows in all the visible values of the dish column in the sales table, brings back burger, salad, and pasta. These 2 derivations over here using the all function, right? They ignore the filters. So all sales dish will bring back all 3 of these, regardless of what I change the filter to. So even if I set the filter to pasta, and I've got a filter for pasta, well, this derivation right here brings back pasta, burger, and salad, because these are the non-respectful derivations, as opposed to the respectful derivations. Okay, so we've been talking a lot without actually doing any of the work of DAX. Any quick questions before we pop in and actually show you this thing working? Okay, so hey, we're going to do this top cell right here where we're doing total sales for the top row for lunch, okay? Now, measures are filter revisers, which means they change the filters before they run some code, before they run some expression. And all filter revisers are always going to perform something called current row filtering or context transition. You might have heard it be called both, right? What that means for us is before the total sales measure runs, before the instructions run down here, the total sales measure is going to add a filter for shift equals lunch. So let's go ahead and simulate that. The total sales measure adds a filter for shift equals lunch because we're looking at that row right there. When we do it for this row right here, it'll add a filter for dinner, but for this one, it's lunch. Okay, so we've got a filter for lunch. And now the measure's instructions or its expression can go ahead and run, okay? So what happens in here? Well, here we've got this derivation where we get all the visible rows of sales, and then we use this iterator. The iterator is going to add this column to that table and sum up the results. Pretty simple. So let's go ahead and grab this stuff. Boom. I'm going to do Control-C, and I'm going to simulate deriving that temp table. Boom. Okay, so we've derived this temp table given these filters right here, which is why we only get the lunch rows. And now the SumX iterator is going to add this column to it and sum up the results. So I'm going to click right there. I'm going to wish I had a backlit keyboard. And I'm going to type in EXP. This new column doesn't really technically have a name, but since it's always based on this expression, I like to refer to it as the expression column. It's a special temporary column. It's only going to be around just long enough to take a sum, okay? And what's the definition of it? Well, for each row, we take the units, we multiply it by the price. Well, I could certainly do that. I bet you could too. The units, multiply by the price. Okay, I'm going to do enter there, and I'm going to do Control-D to drag and drop that formula all the way down, right? So it runs this formula for each and every row. 2 times 7 is 14, 1 times 9 is 9, 1 times 7 is 7, 3 times 9 is 27. And then when it's done, what does it do? Well, this is the SumX function, so it's going to sum it up. If I wanted the average, I should have used the AverageX function. Okay, hold on. Let's see, I do equals sum. Excel junkies could have used the Alt equals shortcut, but I'm doing things the long way. I hit enter and I get 57 bucks, which is the same as that 57 bucks right there, which for what it's worth, I come back over here to my document, is the same as that 57 bucks right there. Okay. Okay, you guys want to see the second row? Let's do the second row. I'm going to reset my filters. And now we're going to look at total sales calculation for this second row for dinner. Well, measures are filter revisers, right? Which means before they run their code, before they run their sub expression, they're going to revise the filters, change them in some way. And in this sense, they're going to add a filter for the current row, right? The row, the value of shift equals dinner, right? Because we just want to get dinner sales. So the measure adds a filter for dinner. And now that we've got a filter for dinner, these are the derivations available to us, right? So what does it then do? Well, same as up here, except now we've got a filter for dinner. It gets all the visible rows of sales, adds this column to it, and sums up the results. Easy peasy. Scoop that up, paste it down there. And we've got our temporary column that's going to be around just long enough to sum up those values. What is the definition of it? For every row, get the units and multiply it by the price. Multiply it by the price. I do Control D to copy and paste that formula down, and then here at the very bottom, what do I do with the results? Well, this is the sum x function, so I'm going to sum them up. 43 bucks, which corresponds to that 43 bucks right there. And I'll go ahead and reset the filter. Any questions about that before we move on to some other examples? Do a time check here. You guys want to see some more? Okay, so based on time, I'm going to jump over here to this average units by type, because I think that's going to be a good one. Okay, so here we've got an average units measure, right, which I'm showing both here and here, because I want to show both the top row and the bottom row. Okay, so it's the same formula, because it's the same measure, right, but it's going to get a different result for the top row and the bottom row, because this one's going to be dine-in and this one's going to be to-go. Okay, so what is this thing going to do, right? Before I actually do it, I'll just remind myself, the measure is going to revise the filters and add any filters for the current rows. For the top one, it'll add dine-in. Then it's going to get all the visible rows of sales, add this column to it, and average the results. Not too hard. Okay, let's go ahead and do that. So the measure is going to add a filter for dine-in for the top row. So let's click on dine-in to simulate revising the filters. Boom, now that we've got a filter for type equals dine-in, our derivations change to just look at the dine-in rows, okay? Now, what does the formula do? It says, go get all the visible rows of sales as a temp table, add this column to it, average the results. All right, here's all the visible rows of sales. Drop that right there, okay? Add this column to it, average the results. Our temporary expression column doesn't really have a name. I like to call it the expression column, because it's based on this expression is the name for that little subformula, right? So for every single row, just get the units. That's it. That's all you got to do. Okay, I can do that. I do Control D to copy and paste that formula down. And before we did sum, because it was a sum x function, this time it's the average x function. So we're going to do an average. Just like that. And what do we get? 1.33, which is the same thing as that 1.33 up there. Okay. Let's do the bottom one real quick, because I think we're getting the idea here. So the measure, average units measure, it's going to start by adding a filter for type equals to go before it runs the rest of its code. So let's go ahead and do that, because we just want to look at the to-go stuff, right? Okay, so now that we've got that filter in place, it can go run the rest of its formula, get all the visible rows of sales, add that column to it, average the results. Easy peasy. Control C to copy, pop down here, Control V to paste. And what is the definition of this super secret, super tiny expression column that doesn't even really have a name? For every single row, just get the units. Okay, I can do that. And Control Enter, and then I'm going to do Control D to copy and paste that all the way down. And when I'm done, I'm not going to do a sum, I'm going to do an average, because this is average X. Easy as that. Okay, and I'll pause again for questions. Any questions? Okay, let's do, let's see, what time is it? My clock isn't lighting up. Let's jump over here. Well, actually, let's do this one. This one's nice and easy. I'll just do the top one, just so you can kind of see it. So what I want to show you here is both a different derivation. Up until now, we've just been using the name of the table, which gives us all the visible rows of the table. Here, I want to get all the distinct dishes. So basically, we're saying for each shift, how many different menu items actually got bought, right? And if you'll remember, nobody bought any salad in lunch because everybody's being unhealthy. I want to show that, right? So here's the measure we can use to show that, okay? So how is this one going to work? Well, we're doing dishes sold by shift, right? So for the top row, the measure, being a filter reviser, is going to add a filter for shift equals lunch. So we can simulate that. Kaboom! Now that we've got a filter for shift equals lunch, it says go get all the visible distinct values of the dish column in the sales table. That's what that is right there. Add this column to it and sum up the results. All right, well, here's all the visible distinct values of the dish column in the sales table, right? Same thing right there, that right there. So here's the temp table that gets derived. Kaboom, right? And what's the definition of our new column? Well, it's even simpler than before. It doesn't even have a reference to one of the columns. All it is the number 1. In fact, I'll do an equal sign to be proper. It's actually a formula. So equals 1. Hey, what does 1 equal? It equals 1, right? So 1 and 1. And what do we do with the results? Well, we sum them up. It's a sum x function. And when we're done, we get 2, which is exactly how many different menu items we sold during lunch. We sold a pasta and we sold burger. Now, we sold many units, but the only items we sold were pasta and burger, which is what we're seeing right there. That's where we get that 2 right there. So we'll go ahead and quickly reset this and do this for the bottom one, okay? The measure adds a filter for the current row, since we're looking at this bottom row right there. It adds a filter for dinner. Boom, we got that filter for dinner in place. Okay, go get all the visible distinct values of the dish column in the sales table. We want that temp table right there. And we paste it, right? We're going to add this column to it and sum up the results. EXP. What does it equal? 1. As simple as that. Hey, Brian, I thought you had to do some complex math thing in those formulas. No, you can just have the number 1. That works just fine. So we get 1, 1, and 1. And when we're done, we sum them up because this is the SUMX function. And who's good at counting? You know what that answer is. Of course, it's 3, which is how we get 3 right there. And if you look at the actual transactions, we only had 3 transactions, 1 burger, 1 salad, 1 pasta. So we sold 3 menu items. Pause again for questions. See anything in the chat window? Okay, let me show you the calculate function, the most terrifying function in all of DAX, which isn't too bad once you get the hang of it, but it is a little tricky at first, okay? So we've already been talking about the idea that a measure is a filter reviser, and what I mean by that is it revises the filters. It's going to change the filters before running some instructions. So for example, here we've got a measure called lunch sales, which we're breaking down by type, both dine-in and to-go, right? So if we think about this row right here, when it starts running, because the measures are filter revisers, the very first thing it's going to do is it's going to add a filter for type equals dine-in. So go ahead and click on dine-in right there. Boom, now we've got a filter for type equals dine-in. We're just looking at the dine-in rows. But wait a minute. The name of this measure is lunch sales. My presumption is if the name of the measure is lunch sales, it should only be showing me sales for, you got it, lunch. So we have half of the filters we need. We've got 1 for dine-in, that's great. But in order to correctly answer this question, we need to add a filter for lunch. And so we're going to use another filter reviser to make another revision to the filters, to create a new set of filters where we have both type equals dine-in and shift equals lunch, right? And that reviser is the calculate function, that big scary function in the DAX language. And really all it does is it changes the filters. It's going to add some filters before it runs another set of instructions. So here what we're saying is, I want to go take this sum right here, but before I do it, I have to add a filter for lunch. This bit right here is just basically saying, go get a temp table that says lunch so that the calculate function can add it. Now let's see how it does it, okay? So here we're going to say, go get all the distinct values of the shift column, visible or not, because the all is one of our non-respectful derivations. I'm supposed to say shift, right? So let's go ahead and grab that, all sales shift. So we get both lunch and dinner, Control C. So we simulate deriving that temp table. Boom, now we've got the temp table, and now we're going to use the iterator to process it. The iterator is going to attach itself and add this expression column, where we're going to say, hey, for every single row, check to see if that row's shift is equal to lunch. Okay? Is lunch equal to lunch? Well, it certainly is. How about dinner? Well, for some people it is, but in this particular data set, the answer is no, it is not. Only lunch is equal to lunch. So SUMX would add up all these values. Average X would average all these values. The filter function's just going to keep the true rows. So what does this thing produce? It doesn't produce a number. It produces a temp table that looks like this. Boom. So it produces that temp table right there. That is a result of this bit of code right here. And because it's the second argument of calculate, calculate's going to take that temp table and stick it up here in the filter context to make it look just like this. Let's see, lunch and dine in. Make sure I got that light. There we go. So now we've got the filters in place. And since we've got the filters in place, calculate says, okay, this thing that we wanted to do, we've got the filters all set up. Now we can go run these instructions. So this bit happens after this bit. This is the bit that happens after we add this filter. Okay, so let's go ahead and do this part. You've seen this before. We're going to get all the visible rows of sales. We're going to add this column to it. We're going to sum up the results. Control C to copy. Control V to paste. Okay. And what's the definition of our expression column? Well, it's quite simple. Go get the units for each row and multiply by the price for each row. I can do that. Units. Who's good at math? What's 1 times 7? Somebody out there certainly knows. 7, it turns out. And we're going to take the sum of it because we're using the SUMX function. And we get $7, which is how we get that $7 right there. Okay. How are we doing on time? I think we're cutting right up against it. Should I pause and jump into Q&A, or do you guys want to see one more of these examples? Or shall I
I think you got time for another example.
Fabulous. Okay. So why don't I do, because I think the calculate function is so scary and trips people up so much, I'm actually going to show the bottom row for this one, because I think seeing this a couple times is quite helpful. I hope, anyways. All right. Millie's in the background. She's excited about it too. Okay, so now we're going to do the same thing. It's the exact same code. The only difference is it's going to execute in this row, in the to-go row. Okay. So measures are filter revisers, just like the calculate function. Both of them modify the filters or revise the filters before running some other set of instructions. So the measure, lunch sales measure, when it executes in this row, adds a filter for type equals to go. So let's go ahead and simulate that. Boom, we add a filter for type equals to go. Filters in DAX are tables. Okay, that's all well and good, but the name of the measure is lunch sales. I don't just need a filter for to go, I also need a filter for lunch. Well, that's where the calculate function comes in handy, right? It's going to say, before we actually go do this sum stuff, we're going to add another filter for shift equals lunch. So this bit right here is going to create the temp table, and then calculate is going to add it to the filters. Speaking of which, let's create that table. Okay, so here's the derivation. Go get all the distinct values, visible or not, of the shift column in the sales table. Well, there they are right there, right? Control C, Control V, right? And then we're going to add this column to it and just keep the true rows. So we got our little EXP right here. So does that equal to lunch? Lunch equals lunch, it certainly does. How about dinner? Nope, dinner does not equal lunch, not at least in this world. And so sum x would sum up these values, average x would average them, max x would take the max of them. The filter function's just going to keep the true rows and produce a table as a result. So what is the temp table that it produces? Shift equals lunch, right? So now that we've got that temp table, which is the result of running this code right here, the calculate function is going to add it to the filter context, and then it can go ahead and run this stuff. So what do we want? We want type equals to go and shift equals lunch. So we'll click on lunch equals to go to simulate calculate adding that filter to the filter context. And now that the filters are just right, Goldilocks, we can go ahead and run this sub expression right here. Go get all the visible rows of sales. For each row, multiply the units times the price and sum up the results. We can do that. There's all the visible rows of sales. Paste it. Okay, so the definition of our expression column is units times price for every single row. Units times price. We're going to Control D to copy and paste it down. And when we're done, what are we going to do with it? We're going to average it. No, we're not going to average it. We're going to sum it up because it's the sum x function. I think. There we go. We get $50, which corresponds to that $50 right there. Okay. Now, I know that's a lot of stuff, but as you can see, the good news is there's not that many working parts and pieces. Basically, you get tables, use these iterators to even turn them into smaller tables or produce a number out of them. And then you use things like measures or calculate, which are the revisers, to just move stuff in and out of the filters. And really, DAX is all about that interplay of those three simple kinds of operations. Okay, so with that, I will say thank you very much for your time. I'm going to pop back here. I do have a closing slide somewhere. Hey, there's a closing slide. There's my picture. That's me. I'm Brian Grant. I've got a blog at CSG Pro. And also, if you like this stuff, we've got a whole new class on YouTube about these elements of DAX. We've got the first, I think, like 6 chapters out. We're releasing new chapters every single month. So if you want to know more about that stuff, by all means, go ahead and do it. And even if you don't, I really hope that you enjoy your journey in DAX. And with that, I will open it up for questions. What do you guys got? I'm going to turn on the light so you can actually see my face. Anything out there?
Yeah. Hey, Brian, I got a question for you, Chris. If you go back to that Excel file, the filter statement on the bottom, on the far bottom on the left, filter all sales. You could just, if I put that into Google Translate and chose DAX on the left and English on the right, what would it say in English?
So what this would say in English, just this bit right here, isolated from all the other stuff, right? It would say, well, I'll be actually very particular about it. It would say, we're going to invoke the filter function. So what we want to do is this filter function wants to get a table. It's going to add a column to it, evaluate a formula for every single row. And then when it's done, it's just going to keep the true rows. So it says, okay, what's the table? That's the table right there. Go get this table. That's what this statement says. This statement says, go produce that right there. And then the filter says, okay, now that I've got that table, I can add this column to it, evaluate this formula for each and every row with a row by row iteration. And then the filter function says, okay, just take the true rows and create a temp table out of it. So go get all the rows, get all the values of shift, visible or not, and just keep the runs where shift equals lunch, is another way of saying that in English. Does that help a little bit?
Yeah, that clarified. Thanks.
Fabulous, fabulous. What else people have out there?
Okay, other questions for Brian?
Sure.
Can you put up your blog URL one more time?
Yes, I would love to. And Greg would love that even more than me, and I'm happy to do it. If you search for Elements of DAX on YouTube, we've got a whole big long series on this stuff. We've got, like, I think, is it 5¼ hours of videos, and we're about 1/3 of the way done through the class, but it's all already really good stuff. So if you like this kind of stuff, that's a great place to learn more about it. And we've even got, and I'm trying not to be too self-promotional here, but we've got this same kind of thing, but you could, we're working to get these Excel documents so that you can actually like download them and sort of go along with the videos and stuff like that. So when I'm doing the thing, you can actually do that same thing. You could do the copy and the paste, and you could add the formula and you could sum it up, and hopefully that really gets it into your kind of fingertips.
Okay, and Christian.
Yeah, go ahead.
Okay, I'll go first. So Christian is asking in the chat window, is M as important as DAX? Do you want to give kind of a contrast between those languages?
Yeah, sure. They do different things. They do different things. I would say, how shall I put this? For an organization, you need both. You need to have at least some expertise in DAX. I mean, you can hire it. You know, there's people, consultants like me, and then we'll come in and do it for you. And we're happy to do it. We'll do a very good job. But somehow you're going to need to have some knowledge of DAX if you want to have dynamic calculations. If all you want to do is produce a flat table and the user can't interact with slicers and they can't cross-filter, well, then you don't need DAX. As soon as you want to have interactions in the report, which is what most people want, that's when you start to need DAX. Now, by contrast, I would say for an organization, you also want to have either a lot of M experience or SQL experience. And I think for most folks, let me come back here, right? So the DAX engine is what creates the summaries on demand. The M engine is what gets data from sources and cleans it up, and it does it every single night. So I recommend for most people that are new to Power BI, DAX is the cool, sexy thing, and everybody wants to learn it, and it is very cool. I like it a lot. It's also very hard and not nearly as forgiving as the M language. So I think for most people, it's a lot easier to learn the M language and do some really cool stuff with it in a lot less time. So I would say if you're an organization in charge of training people up, you're going to find a handful of people that you're going to want to have learn DAX. You're going to want virtually everybody else to learn M, because from my point of view, the metaphor that I've been using recently is M is to Excel like Teams is to email. It doesn't replace it, but what it does is it says, okay, if we were to reimagine this thing from the ground up, knowing what we know now, how would we change that architecture to make it really efficient? M is a very powerful way to have people who are not, you know, math geniuses or anything like that be able to do really cool transformations, and they also do summarizations. They just become static. And I can't, did I actually answer your question? I just spend like 5 to 10 minutes dodging it. Thumbs up, thumbs down.
I'll watch for it. Oh, Christian says you did. Thank you.
Fabulous. Okay, and if there's a follow-up, I could talk more about it. You need them both. If you don't set up the data correctly in the data model, if you don't create what's called a dimensional model with fact tables and dimension tables, DAX becomes incredibly difficult to write, even more so than it already would be. If you set it up correctly, though, DAX becomes a lot easier, especially if you can imagine in your head.
So Olga's asking, should DAX works on every record, comparing. Olga's saying DAX works on every record, comparing B/W. I'm not sure what that means in this case.
I think the question, Mark, I think the question is, where's it better to put calculations for performance between M and DAX?
Yep.
Oh,
Thank you.
oh, that's a big question. Well, I mean, there's sort of four different things. If you need it to be dynamic, you're kind of either stuck or blessed with using DAX, depending on your perspective. So if you want the calculations to respond to slicers, and it's not a simple, what's the word I'm looking for, fully additive measure where it's just a sum of a column, then you kind of have to do everything in DAX. Obviously, if you pre-aggregate calculations at 2 o'clock in the morning, they're going to render faster on screen, but then they're no longer dynamic, they become static. A question that I will often get is, and maybe this is right or maybe it's not, I want to add a calculator column to my data model. Should I do it in the M language or should I do it in the DAX language? Because I can do both. Is that okay? So in that situation, unless you're on an airplane, you should generally try and do it in the M engine. The reason being is when you run these nightly queries to load it, you want that adding of a column to happen here, which is pre-compression, right? If you add the column after the fact, it's still going to try and compress it, but it's not going to do nearly as good of a job. That's especially true if you have a column that has a small number of distinct values. If you do it in the M language, it'll compress incredibly well. If you wait until after it's been compressed to add the column and then try and recompress it, it won't be nearly as fast. So let me know if I answered your question or if I successfully evaded yet another question. Oh, and I can put the camera on. I can see everybody. Wait, how do I do that? I'm so used to Teams. There we go. There's everybody. Hi, everybody.
Hey, Brian, if you were stranded on a deserted island and you could only have 3 DAX functions, which would they be?
Ooh, 3 DAX functions. Yeah, hold on, I stop sharing. Because it's kind of weird for everybody to stare at their own face. 3 DAX functions. Am I trying to survive or am I trying to amuse myself?
Amuse yourself.
Amuse myself? Then calculate, treat as, gosh, I'm going to need some sort of an iterator. Oh, summarize. There you go.
Thanks.
Not summarize columns because it doesn't work in measures. But definitely treat as. Oh my God, the things you could do with treat as. It takes everything I just showed you and adds yet another dimension to it. So something that's already kind of complicated gets even more complex, but it's really powerful.